So, I welcome you all in this fifth lecture of engineering mechanics. My name is Rajat Gupta and I am your mentor for the subject engineering mechanics, and our subject topics are gate oriented. So we are covering the topics which are frequently asked in gate examination. So I am Rajat Gupta and I am taking your subject engineering mechanics. So we have completed 4 lectures till now, and in this 5th lecture we are going to solve some problems, and then we will start the next topic, that is trusses. Clear? So first of all I want to tell you something, that if you are not having the workbook, then you can download the workbook from the link provided in the description box below in this video. Also you can subscribe our YouTube channel so that you can get the notification of the latest videos, right? And also you can subscribe our Telegram channel to clear the doubts which encounters when you see the videos during this lecture. Okay, so we have the channel Mechanical Gate Zone on YouTube, and we have a Telegram channel also, and you can search us on Telegram by the same name, that is Mechanical Gate Zone. So in this lecture I am going to cover two NAT type questions, uh, which in which the students are facing difficulties, right? And I am trying today that the content language, the language of our content from today will be in English, because some of our South Indian friends are demanding the content in English language. So all right, we are going to start the new question, right? So let us begin with this portion. Okay, so we are discussing here two NATs, that is numerical answer type question, means options is not provided you in the question, but you have to solve and then put the answers in the space provided, right? So we are going to do those types of questions. So let us open the workbook. We have the workbook on our left hand side of our screen, and open the chapter number first, and we are going to start yes, we are going to start question number 22. So this is the question number 22, in which the students are facing difficulties and asking many doubts on my Telegram channel. So I am going to discuss this question, that is question number 22, in front of you guys. Okay, so let us begin with question number 22. Question number 22. So here let us first read the question. Wait for a minute. Right. Okay. A rigid rod ABC in the form of a quarter circular arc of radius r is hinged at C and supported by a roller at B. A vertical force P is applied at the end of the bar. For the reactions at B and C to be equal in magnitude, the value of the angle theta up to the 3 decimal points is asked. So in the question given, this is the figure in which C is the roller support. This C is the roller support. Okay, C is the roller support. Sorry. C is the hinged support. C C is the hinged support. So this is not the roller support, this is hinged support. In the question it is hinged at C. So C is the hinged support and B is the roller support, right? And B is the roller support. So a load is applied at point P, a load is applied at point A, then it is asking the value of theta such that the reactions at B and C are equal in magnitude. So how to deal with this question? We are going to start this question right now in front of you guys. Okay, so first of all, let us make the figure for this question. So this is a semicircular arc like this. This is the guys semicircular arc. Okay, and I am making this figure. You should also make this figure in your notebook along with me, right? So here he has marked this point C, and it is mentioned in the question that this C is hinged support. C is hinged support. Okay, and to support this roller, a rigid rod ABC, this is actually a rigid rod A, B, C. To support this rigid rod ABC, a roller support is also provided at point B. So here is the roller support. Here is the roller support, right? And in the question, this line is making an angle. This line is making an angle theta. This line is making an angle theta. Clear? And the radius of this circular arc which the rod is forming is r. Clear? So let us mention these axis. These are x-axis and this is y-axis. Clear? And now an external force P is applied. An external force P is applied at A. This is the external force applied at A. Clear? So this is the situation in front of you guys, and he is asking the value of theta. So that the reaction at B and reaction at C are equal in magnitude. So first of all, concentrate here guys. In the question he is asking the value of theta, which means he is asking the location at which we can he is asking the location of the support B in terms of this angle theta. He is asking that, so that the reaction developed at the B and reaction developed at the C are equal in magnitude. So this roller can be supported. This roller support can be placed anywhere in this region. So at a given angle theta, a point will be obtained where the reaction at B will be equal to the reaction at C in magnitude. So he is asking that angle. Okay, so let us find this angle. So what will be our approach? So the system is in equilibrium guys. System is in equilibrium. So we know that only three equations are there to solve the problems related to the equilibrium. That is, the net force should be 0, and the net moment should be 0. So in case of rigid body, the net force along the x-axis should be 0, along the y-axis should be 0. So these are the three equations, right? These are the three equations. Because this body is lying in xy plane, so I am not considering the force along the z direction. In equilibrium, the force along the z direction should also be 0, but I am not mentioning the Fz should be 0 because this is the 2D structure given in the problem. Clear? So we have these equations. So using these equations, we have to find this angle theta. So observe here carefully what I am going to do here. Okay. So first of all, I am going to draw a tangent. First of all, I am going to draw a tangent at this passing through this point B. So this is the tangent passing through this point B, like this. Okay, and this is the tangent passing through this point B. So it is 100% sure that from the properties of the triangle, for the properties of the circle, this angle will be 90 degrees. This angle will be 90 degrees. Clear? And we have mentioned in the first class of our engineering mechanics that the support reactions are always perpendicular to the point of contact. जिस point पे contact होगा, sorry, I am continuing in English. So the support reaction will always act in the perpendicular direction at the point of contact. So dear, here this is the roller support RB. So here is the roller support. So this roller support will apply a reaction in this direction, and this reaction is nothing but RB. This reaction is nothing but RB. Clear? And C is hinged support. So by hinged support, we means that it will not permit the it will not permit the displacement of this bar at point C in x and y direction, but you can rotate this bar about the z axis in xy plane. This is the meaning of hinged support. So here if you observe carefully, only two reactions will be there at point C, that is along the x-axis and one along the y-axis, because the hinged support will not permit the displacement at point C for the rigid rod in x and y direction. So there will be two reactions in x and y axis, along the x and y axis. So first of all, see here, I am drawing a construction, little bit construction here. I am joining this line like this, and this is angle 90 degree. So if this angle is theta, so this angle will become 90 minus theta. This angle will become 90 minus theta. So this angle will become 90 minus theta. Clear? So we can resolve the components of RB in x and y direction. So how we are going to resolve the component of RB? One component along the y direction like this, and one component along the x-axis like this. So this will be the horizontal component, and this will be the vertical component, right? So this is the horizontal component, and this is nothing but, wait for a minute, right? This is nothing but, you should make a bigger figure so that you can mention all the forces clearly in that figure. Okay, so this is nothing but RB, this is 90 minus theta, and this is theta, so this is theta. So RB along x-axis, the component of RB will become RB cos theta. So this will be RB cos theta, and the component of this RB along the y-axis, this component, ये वाला जो component है, this component will be RB sin theta. Clear? Okay. So we have we have split the RB in the two components. Now we are going to talk about the reactions at point C. Clear? So let us assume the direction. You can assume any direction. Okay. So I am assuming that we are going to use new color. So I am assuming here the along the y direction, this is the component. So this is the RCY. Sorry, this is the RCY, which means that the reaction at the point C applied by the support in the y direction, this is RCY, and a horizontal reaction I am supposing to be here like this, okay. So this is nothing but RCX, clear? RCX. So what I am going to do, first of all, you should make this figure in your notebook, okay. So please try to make the figure bigger in size so that you can mention each and every force very clearly, okay. So at the time of revision you should not feel any complexity in the figure, clear? Right. So this is the, so if you observe carefully, let us mark this point as O. So you can observe that this OC is nothing but the radius of the circular arc. So this OC is nothing but the radius of circular arc, like this R, clear? Okay. And also if you observe carefully, this OB is also equal to the radius of this circular arc, that is R. So if you observe carefully, this distance, this is the angle theta, right? This is the angle theta. So this distance, which I am going to show you here, this distance, I am doing one thing, that I am removing RB cos theta from here, and I am mentioning this RB cos theta here. This is RB cos theta, clear? So if you observe carefully, so this is nothing but R sin theta, because this is R and this is angle theta. So this will become this length will become R cos theta, and this length will become R sin theta, clear? So this will become R sin theta. So this is all about the figure, clear? So what I am going to do in this question, देखिए RB is unknown, RCY is unknown, and RCX is unknown. RB is unknown, RCX is unknown, and RCY is unknown, okay. So what I am going to do, I am using since this system is in equilibrium, so I am using the equation that the net moment should be equals to 0, and I am considering about the point C, because there are two forces, that is RCX and RCY, whose line of action is passing through point C. So their moment about C will become 0, and I have only one variable left, that is RB, and P is known. So I can find out the value of RB from this equation, okay. So let us do this calculation part, that is MC is net moment about point C should be 0. So if you observe carefully, so this is the RB cos theta, and if you observe that the line of action of RB cos theta is this one, and the distance of this point C from this line is this one, this distance. So it is nothing but R minus R sin theta, this R minus this R sin theta. So this will be the distance between the line of action of this RB cos theta and point C, okay. So right, so I am going to write the RB cos theta into the distance that is nothing but R minus R sin theta. So this moment will be about C is in anti-clockwise direction, and I am taking, in this case, anti-clockwise direction is positive. You can take any, depending on your choice. Okay, so RB cos theta will be is equals to R minus R sin theta. This is the this is the moment due to RB cos theta about point C, and in anti-clockwise direction. Also from the RB sin theta, let us clear this. Okay, I am writing once again in a single line. So this is RB cos theta into R minus R sin theta plus RB into sin theta and RB into sin theta. So if you observe this RB sin theta, so the distance of the line of action of RB sin theta from point C is nothing but this distance, and this distance is equals to R cos theta. This distance is equals to R cos theta. So I am writing this as R cos theta. Clear? So this is nothing but R cos theta. Clear? And now the external force which I am applying at point A, that is this force P, is also having some moment about point C and in clockwise direction. Clear? So in clockwise direction, what will going to happen? The moment about the point C due to this force P will be is equals to minus of PR, minus of P and this distance, that is complete R. Okay, so minus PR, and this should be equals to 0. Clear? So now what we are going to do, I am taking out RB as a common and writing in terms of P. So we are going to get what? We are going to get, if you solve this equation, above equation, then you will get RB as P upon cos theta. So this is the equation number first which we are getting. Okay, P upon cos theta. Now, so we have found RB. Now I am going to use the remaining two equations, that is the net force along the x-axis should be 0 and the net force along the y-axis should be 0. So if you observe, the net force along the x-axis should be 0. So the net force should be like this. If you observe the forces along the x-axis, so you will come to know that the forces which are acting is along the x-axis are this RB cos theta and this RCX. Only these two forces are there along the x-axis. Clear? So we are using this fx is equals to 0 first. And using this equation, we are going to solve the RCX value. Clear? So here I am using the fx is equals to 0 and writing the terms which we are getting. So we are getting RB cos theta in positive x-axis, towards positive x-axis, and RCX acting in negative x-axis. So RCX will be equals to, so RCX minus RCX plus RB cos theta should be equals to 0. This implies that RCX is nothing but this is equals to RB cos theta. This is equation number second. So we have RCX also in our hands because RB is known. RB is a known quantity now. We have found RB, that is P upon cos theta, and RCX in terms of RB. So indirectly RCX is also known. Now the remaining last equation, this Fy is equals to 0, which we are going to do. So this Fy is equals to 0. So we are going to get what in this question? So let us do that. So we are using now the net force along the y direction should be 0. So what we are going to do, we are considering the forces that is acting along the y direction only. So we are getting this force F, sorry, I am marking this with a different color. Okay, so we are getting the force that is this P along the y direction, and this RB sine theta along the y direction, and this RCV along the y direction. So these are the three forces along the y direction, and their net resultant will be 0, So net force along the y direction we are going to consider. So what we are having, P upwards in P is in upward direction, RCY in downward direction, and RB sin theta in downward direction. So we are having P minus RB sin theta minus RCY, and this should be equals to 0. So here RCY will be equals to P minus RB sin theta, So we are having this. Okay, so this we are having RCY. So if I am going to mark this as equation number 3, so from equation number first I am putting the value of RB in equation number 3. So I am getting RCY will be equals to P minus P tan theta, because RB is equals to P upon cos theta. So when I place here P upon cos theta, so sin theta upon cos theta will convert into tan theta. So this is the equation. So we are getting RCY as P into 1 minus tan theta. Clear? Also we are having what? I am writing this RCX in terms of RB. So putting the value of RB as P upon cos theta, so I am getting that RCX is equals to P. So this RCX is equals to P. Clear? So the main equation which we are getting here is nothing but these equations. This RB, this equation is our concern, and this equation is our concern, and this equation is our concern. Okay, so if you consider the joint number C, the joint C, so I am going to draw the joint C. See here. So if you consider that this joint is having the two reactions, that is RCX along the x-axis and RCY along the y-axis, but their resultant reaction should be the main concern of our topic. Okay, so the resultant reaction, which will be the resultant of this RCX and RCY. So I am going to write what? If you observe the joint C, so the joint C is having the reactions like along the x-axis and along the y-axis like this. So the net reaction at C, that is RC, will be the resultant of these two. These two are the forces acting at an angle of 90 degrees. So their resultant will be RCX square plus RCY square. So in the question we have to find the value of theta, so that this RC will become equal to this RB. Clear? So this is required in the question. So if you observe, let us calculate this RC first. So RC will be equals to under root of RCX whole square, that is P square, plus RCY whole square, that is P square into 1 minus tan theta whole square. Okay, so this is what we are getting. So if you observe, let us take P as a common. let us take p as a common, so I will be having here 1 plus 1 plus 1 minus tan theta whole square. Okay, so if you observe, this RC is equal to P 1 plus, now I am opening with the identity a minus b whole square, so it is nothing but a square plus b square minus 2ab minus 2ab. So this is nothing but this is equals to p under root of 2 plus tan square theta minus 2 tan theta. So this is the equation which we are getting, that is this is equals to RC. Okay, so according to the question RC should be equals to RB. So RC should be equals to RB, then we are getting that RC will be like this, P under root 2 plus tan square theta minus 2 tan theta, and this is equals to RB, and RB is nothing but where is RB? RB is nothing but P upon cos theta, so I can write P upon cos theta as P sec theta. Okay, so here P and P will get cancel out. I am squaring both sides, so I am will get 2 plus tan square theta minus 2 tan theta, and it is equals to sec square theta. So if you solve this okay, so I am getting here what I am erasing this, right? So this is 2 minus 2 tan theta will be equals to sec square theta minus tan square theta, and it is nothing but it is a trigonometric identity, and it's this identity states that the sec square theta minus tan square theta will be equals to 1. So this is like this. So if you solve this, so you will get tan theta as 1 by 2. What a beautiful problem it was. You will get tan theta is equals to 1 by 2, and if you solve this, then you will get theta as nothing but it is equals to 26.565 degrees. So this is the answer for the question number 22. So I am marking the answer here. Okay. So what we are getting the answer? The answer for this question is 26.565 degrees. Okay, so this is the answer. What a beautiful problem it was. You can observe the beauty of this problem. Okay, so in this question our main concern is to tell that at point C there are two reactions in x and y direction, but we have to find the resultant reaction. Okay, so the net reaction will be the resultant of these two, that is RCX and RCY. Okay, so this is the question which we have solved. Now you can note down the points which we want to do in your notebook. So we have solved this problem. Okay, so I am scrolling the screen for you and holding for a while so that you can write it in your notebook. Okay, so next we have solved the question number 22, and it was a very beautiful problem, and this was asked in GATE engineering science. Okay, so this is the problem from GATE engineering science paper, right? So next we are going to solve the next question, that is question number 24. Question number 24. So we are going to solve this question number 24. Right. So we are having the question number 24 on our screen in the left portion. This is the question. First of all, read the question carefully. The undeformed length of the spring AB is 0.4 meter and the spring has a stiffness of K is equals to 300 Newton meter. Okay, the length of the cord AC in meters. बेटा ये जो आपके पास AC है ना, ये जो आपके पास AC है, इस AC का length is required to find so that this lamp of mass 8 kg is suspended in the position, means it should be in equilibrium, the system is in equilibrium. Okay, so first of all observe the question here. Okay, initially the spring was mounted like this. Initially the spring was mounted like this. This is our spring at the point, at the location B. Clear? And initially I have not attached any lamp in this question. So initially the natural length of this spring is 0.4 meter. 0.4 meter. Okay, so if you going to attach a lamp with this spring, so let us say this is the lamp. ये मैंने एक point से I have represented the lamp with a point. Okay, so I am going to erase it here. I am representing this lamp as this point, this red point. This is our lamp. Okay, so let us make the complete figure like this. This is our lamp. Okay, the mass of lamp is 8 kg. The mass of lamp is 8 kg. So this is the mass of lamp and it is equals to 8 kg. So if you want to find out the weight, so you have to multiply the acceleration due to gravity, and it is nothing but 8 into 9.81 Newton, and it will be equals to 8 into 9.81 Newton. So it will comes out to be 78.48 Newton. 78.48 Newton. And to support this, you have taught a string whose one end is connected to the C and the other end is connected. The other end is connected like this. So this is the string which we have attached. Okay, if you observe carefully here, the string is attached such that the angle made by the string with horizontal is 30 degrees. So in this case, this system, when we attach this complete system to the spring, so you can observe that the spring will get elongated by some distance. The spring will get elongated by some distance apart from its natural length. Means if initially its natural length is L, then after attaching this whole complete system, let us say the length of the spring will become L plus delta L, where delta L is the elongation in the spring, and corresponding to this elongation delta L, the spring will exert a force on this lamp Okay, so that in this direction, because spring will try to regain its original shape, because okay, the spring will try to retain its original state, so it will apply a force on this lamp in rightward direction. Clear? So the corresponding spring force Fs will be is equals to the spring constant K into the deflection in the spring, the elongation in the spring, that is delta L. Okay, and in this direction, since this is a string, so the string will apply a tension, the spring will apply a tension like this. So if you observe carefully, if I want to draw a free body diagram of this, so here this is the lamp, and on this lamp here the force, spring force, that is K into delta L will be acting, and here this is nothing but the weight of the lamp, which is 78.48 Newton, and in this direction a tension force will be acting like this, and this angle is 30°. Okay, so in the question he is asking the length of this string, that is this length. Which length? This length. AC length is asked in the question. So what we are going to do, we are having this 3-force system passing through a point, and in the same plane, means coplanar and concurrent force system, then we can apply the Lemis theorem very easily. So if you know only one force and any one of the angle, then you can find all the forces in the question. So right, so if you observe carefully, so we are having this angle to be 90°, this angle to be 90°. If this angle is 30°, so this angle will become 150 degrees, because the complete straight line, the complete angle should be 180 degrees. Okay, like this. And since this is 90 and this is 30s, so this angle will comes out to be about if you solve this angle, so this angle will comes out to be nothing but 90°, because this is also 180°. Clear? So if you apply the Lemis theorem in this case, so you will get T upon the sine of the angle between this W and this K delta L, that is nothing but 90°, is equals to W upon the sine between the tension and this spring force K delta is nothing but 150 degrees, and it will be equals to K delta L, the spring force, divided by the sine of this angle between W and T, and it is nothing but 120 degrees. Okay, so if you observe carefully, we are using these two pairs, we are using these two pairs we are using in this question, because our main concern is to find delta L here. Our main concern is to find delta L here. So if you observe carefully, the weight will be 78.48 Newton divided by sine of 150 into sine of 120 degree, and it is equals to K delta L. So if delta L can be written as, here we are using the value of K here, and also the value of K in the question is given, how much this 300 Newton meter. Okay, so if you solve this, you can get the value of delta L, means the elongation produced in the spring, you can calculate very easily. So if you solve this in calculator, why I am also solving, so it will be about 0.453 meters. So this is the length, like this, the elongation in the spring which is produce this 0.453 meter. Now if you consider, So this is the elongation produced in the spring. So this means that the the final length of the spring, is nothing but it is equals to L plus delta L, and the natural length of the spring in the question is mentioned as 0.4 meter, and this is nothing but 0.453 meter. So if you solve this, so you will get 0.853 meters. So this is the 0.853 meter, and if you observe carefully, this distance is nothing but this is equals to this much. This distance is L plus delta L. This distance is L plus delta L. Clear? Now in the question, the distance between these 2 points, that is this point, is given to be 2 meter. Okay. So if you subtract L plus delta L from this 2, you are getting this distance. So let us mark this point as O. Okay. So OA. So here OA will comes out to be 2 minus 0.853, and it is nothing but 1.146 meters. Okay, so we have found OA. Okay, so in the triangle OCA, if you apply the cos theta, so it is nothing but OA upon CA, which is the required length. So OA we are getting 1.146, and CA, that is the length of the string which is required. So L will be equals to 1.146 divided by cos of 30 degree. So 1.146 divided by cos of 30 degree. So this is the answer, that is the length of the string will comes out to be 1.324 meters. So this is the length of the string, which is the answer of this question. Okay, so my dear friends, we have solved question number 24 also. Clear? And the answer for question number 24 is comes out to be 1.324 meters. 1.324 meters. Clear? So we have solved this question number 24 also in our workbook. Clear? Dear, question number 26 you should solve on your own. You should try it yourself, because we have covered the concept for the which is required to solve this question number 26, and the answer, you should mark the answer of this question. I am telling the answer of this question. The answer of this question, that is question number 26, will comes out to be 5.17 kilonewton. First you should solve and then check the answer, and it comes out to be 5.17 kilonewton. Clear? In question number 27, the same type of problem we have solved in the above portion, and it is nothing but question number 14. In the previous video we have solved question number 14. Previous I think we have solved question number 14. So the same type of problem is this one, but the he has made the problem little bit complex, because in this case, if you observe, this block can be assumed as a man which was standing in the previous case also. If you observe this case, okay, so this is the man standing on this part. But if you observe, the other portion of the string is perfectly in vertical direction, means this angle is 90 degree. So we have considered only the forces, the reaction developed at A, we have found only along the this direction, because there is no force in horizontal direction, so we have considered only the reaction at in vertical direction at point A. So but in this question, if you observe carefully, this is the question, this is the string which is inclined, this is the string inclined. Okay, so this string will gonna have two components, one is 2 cos heat 2 cos 30 degree, and another one is t sine 30 degree. Okay, so you observe that this is having force along in x direction also and along y direction also. So you have to consider both the reactions, that is rax and ray, both the reaction, but the net reaction is required to be found. So we have discussed the concept, that is the net reaction is nothing but the under root of rax square and plus ray square. So you have to solve this question by making the free body diagram on your own. Okay, so this is the question, and the answer of this question will come out to be 1000 Newton. This is the answer which will you get after solving this problem, right? So question number 27 you have to done by yourself. So I have discussed the question number 22 and question number 24. Okay, so we have put some questions on hold, that is some of the questions, that is question number 23 on hold, and question number 15 on hold. Okay, so this is the all about the statics portion. Now we are going to start the new fresh topic, that is trusses. So I hope you enjoyed this lecture very much. So we are going to start the trusses in a few minutes. Okay, so you can take a break, and in this same video we are going to start the topic truss. So have a break for some time and then continue from this point.